studying graphs, we need to agree upon what a graph is. While we almost always think of graphs as pictures, dots connected by lines, this is fairly ambiguous. Do the lines need to be straight? Does it matter how long the lines are or how large the dots are? Can there be two lines connecting the same pair of dots? Can one line connect three dots? The way we avoid ambiguities in mathematics is to provide concrete and rigorous definitions. Crafting good definitions is not easy, but it is incredibly important. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. The definition is the agreed upon starting point from which all truths in mathematics proceed. Is there a graph with no edges? We have to look at the definition to see if this is possible. We want our definition to be precise and unambiguous. But it also must agree with our intuition for the objects we are studying. It needs to be useful. We could define a graph to be a six-legged mammal, but that would not let us solve any problems about bridges. Instead, here is the standard definition of a graph, at least as of right now. A graph is an ordered pair, G, which is a pair of vertices and edges, V and E, they're sets, consisting of a non-empty set, V, called the vertices, and a set E, called the edges, of two-element subsets of V. Strange. Nowhere in the definition is there talks of dots or lines. From this definition, a graph could be just like a pair of two sets, say, there we go, say A, B, C, that's the V here. And then our edges, we could say are, I don't know, we can connect, actually let's do a three sets here, or four vertices. And then our set is going to, our set of edges is going to be the sets AB, which means vertices A and B are connected. Let's connect AC, BC, BD, let's do CD. And I think that's it. Let me make sure. Yes, that's the one I want to use. Here we have a graph with four vertices, the letters A, B, C, and D, and five edges, the pairs AB, AC, BC, BD, and CD. Looking at sets and sets of two-element sets is difficult to process, so I understand why this might look a little weird. That is why we often draw a representation of these sets. We put a dot down for each vertex and connect two dots with a line precisely when those two vertices are one of the same. Oops, let me try that again. There we go. I'm gonna need a little bit more room. If they're one in the, specifically, we connect a line precisely when those two vertices are one of the two-element subsets in our set of edges. Thus, one way to draw the graph described here is like this. We can draw our A, B, C, D here. And then we could draw a line between A and B. And let me use a different color for the edges. That's A and B, A and C, B and C, B and D, and C and D. Okay, however, we could also have drawn the graph differently. There are many ways to draw this graph, in fact. And I'm going to leave a little bit more room here. We could have done A here, B here, C here, and D here. So that's A, that's D, that's B, that's C. And so A is connected to B. A is connected to C. B is connected to C. B is connected to D. And C is connected to D. And I got that wrong, didn't I? I messed up. No, that's right. Yeah, that's right. Okay, perfect. Here's another example. We could do A, B, C, D. And so in this case, A is connected to B, A is connected to C, B is connected to C, B is connected to D, and C is connected to D. So these are all different ways of drawing the same graph here. They're all the same graph. And this definition, I think, is the best because it allows us to say that in this scenario, it doesn't matter really how we draw these graphs. They're all really the same so long as you label correctly. Anyways, thanks everyone, and I'll see you in the next video.